Alright, Crewton Ramone's HouseOfMath.com. This is the second of 3, possibly 4, videos on deriving the quadratic. But think about how powerful this is. This is in 45 minutes to an hour, hopefully 45 minutes or less, you'll have a solid understanding of the quadratic equation. And this is like, one of the milestones in algebra and so forth. And any 10-year-old, 11, 12-year-old kid can do this. Seriously. Most kids don't get it till they're 16, 17. Some of them not till college. In my own experience, I remember being a sophomore in 10th grade, and basically what we got was, here, memorize this formula. And here's the page on how you derive it, because the textbook had a page on how to derive the quadratic. But of course we never went over it, because it's just memorize this and move on. So rather than memorizing, let's understand what the heck it is we're doing, and let's take a look at several things having to do with ax squared plus bx plus c equaling 0, and how this helps us solve for x. And being able to use this quadratic, we can use it on any second power expression in algebra. And then it helps us for graphing, and it's a rather important little piece of information here. And it's a powerful tool in your algebra arsenal. So you should understand what's going on here. Alright, enough about that. Let's take a look at what we've got here. Basically, like I said earlier, all it is taking this and shaping it into a square and taking everything else we don't like and putting it on the other side of the equal sign, and then solving for x. So if you remember, let's go over it very quickly from last time. And oh, by the way, don't send me lots of emails. I realized that when I rewrote this right here, I left off the x. I see that. Of course, every time I watch one of these videos, I cringe. Trust me, there's 100 things that I could have said better or should have said differently. Let's see here. Let's zoom in and go over this very rapidly. Alright, so in the way that we did it in the last video, we just made sure that we got rid of any possibility of there being more than one x squared, so that we'd always have an x squared here. Okay? So we just divided by however many, no fun, get back to 1, however many a we had, in other words, however many x squareds we had, if we just divide by that number, we always get 1, right? So we divide everybody, and then proceed to solve for x. Simple. So here, we turn it, and the way we do this is by completing the square. So here I complete the square with this, because I know that all I have to do from completing the square, which makes it algebra easy, is take half of this, and then put it on the two sides of the x squared, and then complete the square. Now this is in the way, so we moved it over. Right? We've got it on the other side of the equal sign. Put it over there with 0. Complete the square. Right? Now I have this. Very simple. And then I'm just going to take these two guys and combine them, add them together. Even though it's subtraction. You see that symbol there says subtraction. But isn't subtraction just combining? Right? Just putting this and this together. And another word for combining in kid speak is add. So really there's just adding. There's not really any subtraction. Here we can go, now that I have it in this form here, there it is. If I square root it, I can go directly to this. But to make it absolutely clear what we're doing, what we have is this is the complicated way of saying this, right? So here's the whole rectangle. Here are the two sides, literally. So when you look at this, let's zoom out a little bit. You can see, oops, because I was fooling around with my piece of paper, you can see that this side is x plus b over 2a, and this side is x plus b over 2a. And by the way, do you see now that we complete the square? And I went over a little bit, if I know this side of the rectangle is x, then that side of the rectangle has to be 1/2 b over 2a. Okay, and when I square those two, I get that. Now, look at that, 4a. What if I multiplied by 4a? Isn't there a saying somewhere that you never really know how to do something until you know how to do it more than one way? So I'm going to do it 3 ways. This first way, which was pretty complicated. This next way, which is going to be very, well, hopefully it's going to seem much easier to you. And we'll talk about why, because we're going to multiply instead of dividing. And then another way that's just playing around with algebra and having a fun time. And down here you can barely see it, but that's supposed to say b over 2a. So basically what I have is the two sides of the rectangle, and I am multiplying them together. And that's what it is right here. Right here. So then I take one side, because I just want to know one side. Okay? You can see that when I'm playing with the little kids, where we just take a look at that one side when we do x squared and so forth. A little description here. And Now when I do that, I get this. And when I square root that other side with all that stuff we combine and put together, I get this. And then it's very easy to just add them together, and there you go. Now, here's a quick lesson plan, and there it is, right? There's our happy quadratic, the whole point of this, getting to the quadratic equation. Now, the whole point of this is making it easy and accessible to students. And by the way, just briefly, you spent your whole life learning math, and now you have a degree on the wall, and you're in a university, or perhaps you've set up some kind of program for learning mathematics, or even schools, or schools of thought, and then some guy comes along named Jerry Mortensen, or myself, or other people that teach math this way, there's a few of us, and we say, any little kid can do that. Do you really think these guys are going to get behind us? Do you really think that a person that has a degree on the wall that says they're smart, and they know that they're smart because they can do this and you can't, is going to get behind somebody that says any 10-year-old can do this, any 12-year-old can do this? Really? Anybody can understand this? Really? There you go, talking conspiracy theory again. But no, seriously. I've found this over 20 years of doing this, since 1990. It's now 2010, we're heading into the end of 2010. It's November. Anyhow, here, for little kids, for, say, 10-year-olds or 11, 12-year-olds and so forth. And you can even do it with kids younger than that if you've been playing with this since they've been, since this is their first math experience and they're 4 or 5. By the time they're 7, 8, 9, 10, getting to this was not going to be that big of a deal. Anyway, take a piece of paper. Look, it's a magic piece of paper. Fold it in half. Fold it in half again. Fold it in half again. Right? Okay, so, because we're going to use each one of these spaces to take one of the steps that we do for deriving the equation. And, oh, look at that. There it is. And you can see that it just makes it easier for them to take it. Or they can use filler paper, but sometimes it's just nice to have a big piece of paper like that. Anyway, you take a piece of paper like that, and you can write out the steps. In fact, if you look at my paper, you can see that I have little lines there, so it keeps, my symbols in check, so that they don't wind up all over the page. All right, so let's take a look at this, and we're going to do some multiplying instead of dividing. Okay, so here is a squared plus bx plus c, where we start off every time equal to 0 with our 0 there, and the shape we're going to go for is this square, right? Okay, so first thing I'm going to do, and let's understand why we do these things. I'm using my imagination and assuming, or knowing that this is a little tiny shrunk down x squared. So A says I just have some number of them, I don't know how many it is. So if I get 1, it's perfect. But what if I get a problem that has 2x squared, or 3x squared, or 4, or 5, or 6, or whatever? Well, actually 4 would be nice. So all I have to do to make this into a square, the shape that I'm going for, is multiply by a, right? So if it's 2, look, I get a square. If it's 3, I get a square. 5, 6, 7, 8, 9, and so on. Alright, so that's what I'm going to do. I'm going to multiply everybody by a so that I can guarantee that that shape right there is going to be a square. So that completing the square becomes very easy. Alright, so everybody's been multiplied by a. I got a squared x squared, abx plus ac equals 0. And trust me, it actually makes it easier. And look, hero 0, he is impervious to multiplication. He's impervious to division. I can multiply him by a, I still get 0. I divide by a, I still get 0. Alright, now, let's take and make sure that I have an even number of these to put around my x squared, or my a squared, x squared, however many x squared I have here. I'm going to have half, right, and put it on each side. You've seen that from completing the square. Well, what if this number, ab, a times b, was a half? Well, if I multiply by 2, that just becomes 1. And as we saw, if I have just one x, it's hard to split this guy up. And so we're going to make it easy. We want to make it so that we have an even number of these, and we can split it up and put it on either side. Okay, so what number am I going to multiply by? I'm going to multiply by 4, right? And oh, look at this. Look, it's still under there. Can I see it? Yep. Oh, look. Right? Oh, and you're going to see that it's going to be so much easier when we complete the square in just a second here. Alright, so multiplying by 4. Alright, that's simple. Now everybody's been multiplied by 4, and again, 0, impervious. Alright, so what do I have here? 4AC. Oh, that sound familiar? 4AC. So now I'm going to complete the square, and I'm going to move this over here. I'm going to move it. It doesn't walk across the equal sign and become negative. What I have is 0 over here, which is 4AC minus 4AC. And when I find the stuff that's same on both sides, that's 4AC, leaving me with a negative 4AC. Right, we've seen this numerous times, so I'm not going to show it. That was the bank error in my favor. Just kidding. Let's see here. 4a squared x squared plus 4abx. What would complete the square? Well, that looks difficult, right? Oh, look at all that. But let's draw a little picture of it and see how easy it actually is to complete the square now. Alright, you see here I have that basic shape and I just broke it apart. Right? That's the same shape I had from before. There's my x squares. Here's going to be my bx and so on. But alright, so let's see here. What I said is I have in this corner a bunch of ax squareds. In fact, I have 4 ax squareds. That's an ax squared, that's an ax squared, that's an ax squared, that's an ax squared. So one side of that, pretty simply, would just be 2a squared x squareds, right? 2ax. And this side would be 2ax. See that? So when I multiply 2ax times 2ax, what do I get? I get 4ax squared. A squared x squared. Oh dear. Right? See it there? There's my 4a squared x squared, because I'm just figuring out what I'm going to have in each one of these. Alright, so now that means that I'm going to take, what am I going to do? I'm going to take half of this and put it on each side. So I'm going to take 2, what is it? 2 what? 2abx, right? That's half of them, right? 2abx. See? Oh, look, no more fractions. 2abx. Right, this is me putting it on the two sides. Okay, well I know that the one side of this 2abx is 2ax, right? Because it's together. It's actually what I have here is this, right? And I just blew it apart. So anyway, this side must be 2ax. So what's that side? Okay, I got 2ax. Well, this side's got to be b. That's it, just b. So over here I have 2ax, and this side has to be b, right? Or I can look at it the other way, where I say this is 2ax, and this side has to be b. Let's do it that way. So it's positively, absolutely clear. In fact, look, 2ax, 2a. Oh, there you go, right? Okay. So this side's b, and this side's b. So that means on this one is b, and this one is b. So what goes in there to complete the square? Just b squared. Super easy. See that? That's how we complete the square with b squared. Okay, so I complete the square with b squared. Of course, I have to add it here, so I have to add it there, right? Oh, look, b squared minus 4ac. Oh, we're almost there. Alright, so what's one side of that? One side of that whole thing, on this side of the equal sign, is 2ax plus b. Any of it, it's no matter where I look, it's 2ax plus b. It's 2ax plus b over here. It's 2ax plus b over here. It's 2ax plus b over here. Because the shape that I went for was a square. So this whole thing, when I factor it, turn it into a perfect square, which is the whole point of doing that. One side is just, well, okay, we're going to factor it and then show one side using square root. And there it is. Do you see how easy it is? There it is, factored, right? Perfect square. Now I just square root both sides. And then what happens? Well, you'll see, it's very easy. Don't forget it has to be plus or minus over here, right? Now it's super easy to solve for x, right? All I gotta do is subtract that and divide by that, I'm done. Watch. So once again, there is hero 0 right there, right? There's got to be a b minus a b over here. So when I find stuff the same on both sides, I'm just left with a negative b. And now what? It's no fun. Get back to 1. That's it. What am I going to do? I'm going to divide out by 2a. That's it. So I divide that by 2a. Divide this all by 2a. And I'm left with 1x. Done. And there you have it. Crewton Ramone's HouseOfMath.com for more. Stay tuned for yet another video where we cover this.